Hey guys, in Module 1 you're going to be looking at a variety of tasks. This overview should help. When you get to Module 1 you'll have downloaded a assignment. The module starts off, of course, off of the course website. And the first thing to do is probably watch the course overview video I made you, and then specifically click on the assignment. From there you'll be able to go through and download the details document. You also have access to various videos I post that are part of describing the module, such as the one you're currently listening to. In here you'll find the list of modules I want you to watch. I recommend you just watch them in order and then go through, and from there start looking up some information about the topics of working with, it's an interesting artifact there. Not sure what's up with that, but okay. The topic of working with various different batch files and how Python files are similar to batch files. Also, since many people have not used batch files in a very long time, or they never actually had to use them because they're kind of newer to the computer world, there's a little video on how they're used. I think it'll help you understand why Python scripts are made and where they fit in the scheme of life. You'll also find some activities I want you to perform, and I want you to be able to go out and document what you've learned. There is a link here to help you understand what I'm looking for as far as formatting of the document. It is very important that you do. If you do not format it professionally, if you do not format it professionally, it doesn't have to be perfect, but your name has to be there. You have to cite your resources. If you don't do that, I will not accept it. You've been warned. And zip up all your files, including your batch file and your script file and your Word document that you make, etc. Zip it all up and upload it to the Canvas site. So I'll keep you pretty busy this week. I expect it to take between 6 to 15 hours. Please plan accordingly. In this video, I want to talk a little bit about what Python is. Python's a programming language that's only been around for, a few years relative to other programming languages. By that I mean like a decade or so. It's a nice, simple to use and learn language, and it has some really cool features, such as it runs on just about any operating system out there. Windows, Linux, Unix, Mac OS, not a problem. It has been ported to other environments as well. One of the common uses of Python is simple automation. So simple little tasks that you want to do with a click of a script, and it kicks off the task and it does something in the background, and then you're done. It's great for setting up test labs. It's also great for doing more advanced things like automation in an assembly line using various little mini computers. So for that reason, it's become a quite popular language. Another reason why is it's free. It's easy to use. If you're using a commercial products, it's easy and free. If you're using it for home, it's easy and free. It's also been approved as open source, has a licensing agreement. So overall, it's popular because it's free, and that means all the way across the board. Another thing, there are a couple of versions of Python, the version 2 and version 3. There's a great controversy about which Python is right for you. The link will bring you out and you'll be able to read more information about it. In general, Python 3 is going forward. Python 2 is for backwards compatibility. There are a lot of people still using Python 2. It's not that Python 2 is bad. It's just that it's not being improved on at this point in time. There's no indication it will be. People are encouraged to move to Python 3 at some point in time. If you're learning Python 3, like we are in our class, most things that you do are applicable back to Python 2. If you, for some reason, have to take this course and use Python 2, then that is fine, but be aware that you will have to look up on the internet when things go wrong what the difference is between a command in Python 2 and Python 3. Now, I will try to catch those and tell you about when they occur, but I may miss them. So it's your responsibility if you want to only try to use Python 2 because your work uses it. Other than that, I strongly encourage you to use Python 3. For more information about what the differences are, this webpage link should help. The book uses 3. That's one good reason for it. And also, I'm going to talk about object-oriented programming in later videos, and 3 is better at that as well. There's also a nice little video on here talking about some of the differences. Worth your time to go look. Now, to use Python, you have to actually go through and install it. Installing it's actually pretty dang easy. Going out to the website, go to the front page, maybe not the front page, click on that link there, and you'll see an option here for downloads, and you can choose between version 3 or version 2. Version 3 is 3 with some change after it. Version 2 is 2 with some change after it. Again, we're using 3, so I'll click on that link. I just go through and download it. If this is for Windows, if you're not using Windows, go to the full list here, and looking for Mac, click on that link, and then follow to click on the installer, depending on your operating system. The Mac installer, as usual, is really easy to set up. The Windows installer is not that much difficult either. Once you've downloaded the file, I'll go on your HUD. Let's see, be in downloads, I guess. Once you've downloaded the file, you go in here, Python. Okay, well, be that way. Download it again. Aha. That just so makes sense. Okay, once you've downloaded this file, you just right-click on it and go ahead and do the install. It should install in a few seconds, except the default should be just fine. If ever you want to use 2, you can uninstall this one and reinstall 2. There's also some videos out there how show you how you can switch back and forth. Now, once it's installed, you'll need to go through and try it out. So the way to do that is, if you're in Windows, go to the Start menu, click on your Python 3, whatever it is there, and the menu, Start menu choice. Choose idle from the sub-menu, and when you do, the Python shell should open. I'll go ahead and do that now. Can't really see it here, so that's why I put the little screenshot up. Okay, Python 3, idle, and now the little window pops up. Now with that window in place, I can actually start typing some Python code. Rather, one of the first things you learn is how to print something out. This editor is not fantastic. We will see a much better editor at a later point in time. But for right now, it's a good way to get started. When you're done typing in your code, you hit enter. It will actually do some kind of action. If you want to repeat your code, actually I thought you could do that. That's sad. Guess not. It's a very cheap editor. There we go. If you're using 2.7, print statement's a little bit different. You don't use parentheses. If you're using Python 3, you need the parentheses, so that's one of those differences. Anyway, again, I'm going to be using Python 3, so make sure that you realize that as you follow along. If not, you're going to have to do a little extra work to get it to work, but I have had plenty of students who actually have learned with Python 2 successfully, even though this class focuses on 3. Okay, that should give you a start on what's going on here. Next thing we're going to talk about is console applications. Until then, hey guys, in this video we're going to talk about console applications, what they are and how they relate to Python. So console applications are something that many people in the industry used to use all the time, now not as much. The basic features are that it is working with the operating system shell environment. Console applications are available on pretty much any operating system. On Windows, we get so used to working with a Windows environment, we don't even think about them being there until we need them. The way you open them in a Windows application is you go to the Start menu, and where it says Search, or where it says Run, you would just type in CMD. It will bring up a command shell. From there, you can type in command shell, well, commands, such as, let's change the directory to semicolon. Oops, change directory to semicolon. Okay, change directory to C. I hit the up arrow to type it in, semicolon backslash. There we go, now you got it. If you want to clear the screen, you can type in CLS, yay, or dir for directory listing. Now, there's a number of simple applications that are built to run directly out of the command module. So this command shell. Most of the time, they're just utilitarian commands that are used by administrators and not by novice users. Python usually falls into that category. Often when you make a Python program, it's something for administrators to run, or people setting up test labs, or setting up simple automation, but it's not made for just everybody out there, such as somebody that doesn't really use computers other than to answer the email, or make Word docs, or various other tasks that are very important, but they're not administration level, developer level tasks. So from here, I would go ahead and launch Python by typing in something like Python .exe. If I usually put a question mark, it'll give me information about how to run something. Now, Python.exe is actually running as a console application. When you put the question mark in there, most applications will do this. Will give you additional information about how you would run something. Here's another example. This is built into the system. It's called ipconfig. And if I put a question mark there, it also gives me information about how I run this application. ipconfig is one that you actually may have used in the past, especially if your internet connection went down. It gives you information about the connection, the configuration on your TCP/IP connection, such as what is your IP address and what is the address of your router and various other things. These kind of applications are simple to use, and if you're a fast typist, I'm not particular, but other people are, then you can actually speed through a lot of simple tasks. Much easier than having to grab the mouse, move things around, tab around, and the like. Simple data entry is often performed fastest if you use a console application. But another reason for it is just to obscure things such as you don't want people messing around with the IP configuration. If you'd like to see how a Python script's going to work, let me just show you a quick example. I'm going to go through and open up that Python editing program. Let me see here, where did I put it? I'm opening up the idle application. And earlier I had created a file that had a very simple test. Oops, let me do this again. Test command. I'm actually going to go through and make a new file. I'm going to call it test. Oops, excuse me. I'm going to put in the code for printing out test. And I'm going to go here and I'm going to save it. Now, I probably should save it someplace that's easy to get to. I'm going to recommend you guys go through and on C drive you make a folder and call it Python class. And then that Python class, I'm just going to go ahead and put various files. One that I use all the time is test.py. If I ever make changes to it, I can just save it, and then I can run it from the console command. Like over here, I would type in Python, the name of the file. Oops, I got to tell it where it's at. Then the name of the file. And there you go. It goes ahead and runs the code inside. If you want to type it in again, you can use the up arrows. Up and down arrows will navigate through your previously typed commands. And as you can see, it's pretty easy for me to run it again, and again, and again. Later on, I'll tell you a little bit more about batch files and how they are used to automate the process of typing out this long command. But for now, let's give you an idea of what a console application is. It's very simple, it's easy to use, it's fast, and a lot of Python scripts are created just to work within the console. Take care. Hello, in this video we're going to look at programming basics. Programming is the art of going through and creating various statements, grouping them together to perform various actions, usually upon various pieces of data. And as such, programs break down into two categories. You have a category of items that consist, that make up the data you're going to work with, and the operations you're going to use almost always against that data. So the data would be things like a person's name, a phone number, any piece of information, any fact. Operations are the thing you do with that data. So let's say I have a fact that's a value of 5, and another fact that's a value of 3. I could have an operation that would add those two numbers together. So 5 and 3, the operation would be the thing that I want to do with that data. Now, programming also have things like comments, namespaces, directives, and statements. And you can think of it like this. Let me see here. This is a programming statement. This is some data I want to use. This is a statement that uses that data. Now you can see that my first item doesn't actually show up as being anything other than storing the data. Basically, the way you read it is the values AAA go into this variable. Now the variable, I'll talk more about variables later, could be called X, could be called Y, could be called Z, could be called anything you really want. I called it str data. That's just because I like calling it that. str stands for a string of characters. Data, just because it's holding data. And then if I make a statement like this, it's performing an operation, but not really using the data I made previously, although the string inside here is also data. And if I print it out down here, this is performing an operation against the data I made on line 1. Anyway, data and statements. Those are things you constantly use all the time. As I'd mentioned, you also have comments. Comments are just little notes to self. Nah, to self isn't exactly right. This could be to somebody else that opens up your program at a later point in time. They don't actually run. They're just sitting there as little notes. You can even use this technique to make a line stop running. If I put a comment in front of it, it stops running. I'll come back to comments in a bit. Directives, namespaces are ways of kind of organizing your code. The idea is that if you have, let's say you have a function, or let's say you have a 5 or 6 statements, like the ones we just put together. You could group those statements by putting a namespace around it. It's a very common technique in many programming languages. We'll see something similar in Python later. Directives are some kind of statement that allows Python to perform some kind of additional functionality or provide additional information about the program, but it doesn't actually run per se in the program. So I could go through and put in I could tell it I want to import some kind of module, and it doesn't actually run per se. It just is telling the program that I'd like something to happen like in the background. This is referred to as a directive. Statements are these little guys right here. That's a statement, that's a statement. This is a comment, that is a commented out statement. No, it's just a regular statement. It's one instruction to the computer. Each instruction or statement is made up of one or more keywords. And these keywords or symbols sometimes are called tokens. So for example, a statement could be so this is a statement. The statement's made up of text that you type in. Sometimes it's made up of commands, like print is a command. Sometimes it's made up of these little symbols, such as a plus, which when I run it, it performs an action, but it's just a symbol that tells it that's part of the statement. Again, sometimes it's referred to as tokens. Python also ends their, in Python, you indicate that you're done with a statement with a carriage return. It's not happy about that. It's because the carriage return basically said, I am done. New statement. So, because it's an invisible character, it's kind of hard to see, but it was there anyway. Python picked it up. So carriage return is how Python indicates an end of statement. Another way you can indicate that a statement's over is by putting a semicolon. And semicolon is a very common way to indicate that a statement is over. Let me clean some of those out here a bit. In Python, it's optional. In other languages, it's mandatory. So like in C or C#, it's mandatory to have a semicolon at the end. JavaScript and Python, it's optional. You can put it there, you can leave it off. One advantage of putting it there is that it actually does indicate that you're done with the statement. Python's a little bit confused by what the heck I'm trying to do there. That's because I don't have a carriage return indicating my end of statement. Put a semicolon there and see what happens. Now it understands because the semicolon indicates I'm done with that line of code. I'm done with that statement. Some people find putting semicolons at the end of their Python code against their Python religion, so to speak. And they think that it is a sign of novices to use that because it's one extra stroke of the keys that you just didn't need. So Python faithful, as I put it here, may consider this wrong, but I'm not one of those folks. I think it works just fine. It's a useful tool. I kind of prefer putting it there myself, but since people in general don't, I often will leave them off. Here's an example of these statements. X is equal to 4, Y is equal to 5. I just made up some names. And then X plus Y equals Z. I'm going to go ahead and copy that code. I'm going to paste it in my little Python shell, command shell here, idle. And I'll go ahead and run it. These are 3 statements. But although the statements run, I don't get an error message. The thing is, they don't actually do anything. Well, that's not quite true. They don't present anything to the end user. Some statements will run invisibly in the background, but without any output to the user, such as a print statement, not really going to notice much happening. Not that that's bad per se, but it's always something to keep in mind. Some other things I should tell you. In the world, some people think that writing your code without any extra spaces just makes it so much better. It still works. Other people think that you can really simplify your life by just going through and taking those out. Now the code just runs smoother. I'm of the opinion that it is not as easy to read when it's like that. I prefer to have spaces. This is a matter of preference. And some people will kind of balance it out by doing all kinds of things. In general, keep the formatting consistent. This is all right. This is all right. This is not all right. Where some are, some aren't. Try to be consistent in that one program, that one script. You don't have to do it forever, but for that one script, you want to keep it consistent. Well, that should get you started on some basics about programming. Next up, let's take a look at comments, a little bit more details. That's coming up next. See you then. In this video, we're going to look at programs and comments. Comments are a way of leaving behind notes to yourself or another developer. The thing about a comment is it doesn't perform any action when the code is ran. While it does exist in there, and it does get read, no actions are performed. That's true if I put a pound sign in front of the actual statement I have here too. Test actually is printed, but the 9 never comes up. In Python, the standard comment is, or inline comment is called, is a single pound sign. In this language, there is no official block comment or multi-line comment. The multi-line comment would allow you to go through and comment out a whole bunch of statements at once. Traditionally, in most languages, you will see something that looks kind of like this. slash, a star, and then a star and a slash. This is very common in the industry. So you'll see it in things like C++ or C sharp or even SQL, the programming language for working with databases. But in Python, there's no official support for this. However, there's kind of a workaround of having a multi-line statement by putting in 3 single quotes. That actually will do basically what the block comment would do. So this now becomes a multi-line comment by just the way it runs. The original developer of this language, Guido van Rossum, has actually acknowledged that this is a cute trick and is acceptable. So although his language that he created doesn't actually have block comments, this whole trick is one way to get around it. Comments are nice to have. They leave, like I said, notes behind, and a lot of times when you go through and you create a program, you'll have hundreds of lines of code. When you open up 3 weeks or 3 months later, you may well not understand what the heck you were thinking of back when you wrote it. Comments can help with that. They can give you information about what you were thinking about and actually help you to interpret what was going on, or maybe help you to change something if you need to update your program. It is strongly encouraged that you use comments throughout your code when you're going through this class. Not much more to say about comments. We'll see how they're used as we go forward. That will probably be more useful to you than going on and talking more about them. So until next time, that's it for this video. Take care. In this video, let's talk about case sensitivity. In the early days of programming, there was a decision made about how character data should be stored and represented on a screen. Humans want to see characters like A, B, C. The computer, of course, works by numbers. So it turns out that the way they decided to design this was each character would have a numeric value. For example, a capital A has a numeric value of 65 according to the American National Standards Institute. Capital B has a value of 66, and so on. Actually, a lowercase a has a value of 97 because there's a 32 number difference between uppercase and lowercase. This is referred to often as a shift. So you've seen shifting, like shift and an A would give you uppercase A. Anyway, the deal is that from the computer's level, having a uppercase or lowercase makes an impact in some cases. Now, later on, it was realized that humans had gotten used to writing things and expecting them to work without case sensitivity. So, for example, if I type in dir for directory versus dir for directory, you could either choose to make it so that it will work or not. Microsoft decided that they would just forgive the humans and let it work whether it was uppercase or lowercase. Yes, it would be sloppy, but it would be friendly. In the Unix world, that decision went differently. If the human didn't actually pay attention and type it out as the way they wanted it, it would not work. Part of the reason is it also made it so that you didn't have to do things like, if it doesn't work one way, shift to see if it works the other way. Whatever the case may be, the fact is that in some things, case sensitivity matters, and other things, it does not. In general, if you're working with Microsoft stuff, it doesn't. If you're working with non-Microsoft stuff, it does. Python is kind of a non-Microsoft language. It certainly runs on Windows just fine, but its roots come in from the Unix kind of world. And as such, you can expect it to be case sensitive. So for example, if I type out print, it prints out just fine as long as I get the name right. Let's try another one. Print. Notice that my color coding is out of the way. That gives me a hint. It also doesn't work. It says print's not defined. Now, you will get this error message a number of times in this class. And almost always, the reason why you're getting this is because you misspelled it. It could be, like I do all the time. It's not such a case sensitivity issue, it's just that I reverse letters. I do that all the time. It's annoying as heck. But it does, of course, work the same way if you get the letters in the right order, but you forget that it's the case on it. Case sensitivity is important in Python. Now for humans, and to tell you the truth for Python, the presentation of data, uppercase and lowercase, doesn't seem to have a whole lot of effect. But there's some other places it shows up. For example, let's say I make an if statement. If it's true that, how about we ask if it's true that A is equal to A? Well, the answer to that is yes, it is true. Oh, let me go back here. Otherwise, I'll print out false. Well, A is indeed equal to A, and as such, it prints out true. Now, let's change this over to lowercase a. Run the same thing. And we'll see now we get false, because that is not considered the same. So case sensitivity shows up in a variety of places. It shows up in the fact that when you type out a command, if with a capital I is not the same as lowercase f, or else here, not the same as lowercase f. And of course, when you're using strings for comparison, that has an impact also. Something to watch for as we go forward. It's a simple topic, but it's something that's going to cause you a little bit of grief here and there throughout the course. Next on the list, we're taking a look at what are we looking at next? Something a little bit meatier. It is going to be talking about functions. See you there. In this video, we're going to look at functions. Functions are a nice way of going through and grouping statements together. You see, what happens is that a lot of times you'll have comments and statements and all kinds of things going on, and you'll want to group them together as a unit. So the way you can do that is you put the word def, or definition, to define a function. You make up a name, throw a couple parentheses together, a colon, indent some code, and that's it. You've got yourself a function. Let me show you an example. This code doesn't do a whole lot, but it tests to see whether something is true or not. So let's say I want to wrap it up in a function. I type in def, I come up with some kind of name, I don't know. Just make up a name. And then you indent it. You notice that when I made the if statement, I had indented the print statement, and that's important. Python looks at the indentation and makes a decision about what you're trying to say based on indentation. So I need to indent that also. In this case, I entered, I think, a tab. Oops, heck, I forgot the if. Lower this down from the last demo. That's not going to work too well. Okay, so it would be tab will work. A couple tabs. The key in indentation is being consistent. Okay, that's it. Now, that is all you really need. The fact that the code's indented indicates to Python that those statements are grouped under EIEIO. Only test ran because I never called the function. but the function actually loaded up into memory. So the deal is that it loads that code but doesn't actually run it. To run it, you need to call it. Calling is just referring to it by name. And you can see that, test to see whether or not it's true that A is equal to A. And it turns out that that's false because of case sensitivity. But it did run the code. Of course, I think I'd give it a better name. Demo method's certainly better than EIEIO, but I think you get the idea. My preference is to indicate to people that the function ends at some point by just putting in end the name of the function. That is a personal preference. Not everybody likes it. I just think it makes the code easier to read. But again, that is a personal choice. It turns out that the script as a whole represents basically one function, or sometimes functions are called methods. This actual script runs under what you might imagine as a main module method function. Most applications in the programming world have this. They have a main or starting point. The main method or starting point or module function, whatever it's going to be, as soon as you start your program, this little hidden collection of statements starts to run. Any code within that main module or method will actually be processed top to bottom. In this case, you can't see it, but main would basically be from here to here. In other languages, like C#, it's explicitly defined, making it easier to locate and figure out what the heck's going on. To tell you the truth, it could be very easily argued that since I've got a function defined there, you could argue it actually would start here. Although we'll see a little later on why that's not exactly true, but still, I'll think of it that way. So there's an invisible starting point, and what's going to happen is that any functions get declared at the top, and then any code after that will be part of the main method, module, whatever you want to call it. In this case, this code gets loaded in memory, but the code actually starts processing right here. 1, 2, 3, up and done, and you're out. Here's another example. Let's say I go ahead and I type out demo method. I've got a print statement, and it ends. When I start the program up, it will jump down here and start after my declaration of the demo method's definition. It will do something like print out something in this invisible main method. It will call demo method, which jumps up to the top, starts working its way down through those statements. As soon as it gets to the end of those statements, it jumps back to where it used to be and continues on until it finally gets to the end of the program. That is the way it works. Now, you may be wondering why it's all that important. We'll see why it's important as we go forward. But like many things, especially in the beginning, just talking about it isn't all that helpful. You just have to kind of work with it a little bit, and I'll point it out as we see it happen. There are lots and lots of functions that are built in that you don't have to make on your own. An example is the one we've been using quite a bit of, print. Print is a very easy function to work with. There's actually a number of different options you can add on with print I just haven't talked about yet. And so, while it is true that it is an easy function and very useful to get started with, there are some more options we'll see later on. Another one that's really easy to work with is the input statement. This is kind of handy because it allows you to get information back from the user. Now, when you run this, the program will pause and wait for you to type something in. That's interesting. I shouldn't have done that. Oh, that's interesting. There we go. I must have hit the up arrow. Up arrow typed out my previous code earlier. So anyway, input allows you to ask a user to type something in, and you can go through, excuse me, and do something like this, where you say, let's capture the data. So I'll make a variable called strdata, and I'll set it to whatever somebody types in. And I'll print out the data, and now I'll see what the user typed in. So enter allows you to enter data in, print allows you to print data out. If you're using version 2, input's a little bit different. You have to use raw input function instead. So let's see, and I think it's without parentheses in this case. Same kind of function, just a little bit different. This is one of those differences that can cause you some grief. If I go through and let's say I have Python mapped over to run as off a command window. So for example, I have, let's see, where do I have this Python? I got a bunch of stuff in here. I think I'll get rid of some of it. I'm not sure where I've got that either. Okay, yeah, actually, should have got rid of that one too. Let me save my work. There we go. So I got this one file in here. Right now it's mapped over to be opened with PyCharm, but I'm going to go ahead and change that mapping. I'm going to tell it to open it with Windows Launcher, let's see, Python Launcher for Windows console. It sounds right. Let's see what happens. Ah, dog. It didn't take it. Okay, I'll try again. Just go away right now, would you? Let's see here. Open with, choose default program. Actually, I really want to launch it. Yeah, this should work. Always open with that. There we go. That's what I was hoping for. Now, it wasn't very exciting. You notice that it opens. It's hard to see, but you can see that the command window is opening and then it's closing. Let me change this around. Now let me try. Cool. It opens the command window. I can enter in my name. I hit, oh, hey, way to go. Well, it turns out that as soon as it finished printing out my name, it exited. So a way to stop a program from automatically shutting down is just to put input there without anything else. Nope, I don't want to run it. I just want to save it. There you go. Watch. See how it sits there and waits for me to enter something? Of course, there's no indication that's waiting other than the fact that I hit enter and it closes. So what clever people have done is they put in something like this. I bet you've seen something like this before. editor close. Yep, that'll do it. Anyway, this is the two functions that you're going to find very useful, print and input. We're going to be using it a lot in this course. Very easy to work with, very easy to use. One of the reasons why I bring up both those functions, because the chapter 1 that I want you to read is going to discuss it. In fact, that is the topic of our next video. So until then, I'll see you later. In this video, I'd like to take a quick review of what is covered in the first chapter of your textbook. The textbook in this case is Python Programming for the Absolute Beginner, 3rd edition by Michael Dawson. And in the first chapter, you'll find how he talks about the stuff that we're going to do in here, why he likes Python, and talks about how the book is kind of structured by using Python to create simple games. The games in the first couple of chapters are very simple. As time goes on, they get a bit more complex. And then later, past actually the moment where we start finishing the class, he actually shows you how to make graphical games, such as just very simple base sprite applications. It's good stuff. By the time we get done, you'll be able to continue reading those if you're interested. For right now, we're more interested in just Python programming in general, and chapter 1 just kind of talks about that. To kind of set the theme, he talks about just printing out something called game over and making it so that when you press exit to or enter to key to exit, it would and showing you how that's done. He introduces where Python came from, how easy it is to use, and various other aspects. And shows an older picture of how you install Python. Like any book, it is things have changed as time has gone on. He introduces idle. Idle is that program that I've been using to do the demonstration so far. This is idle. And as I showed you in an earlier video, it can be opened from the start menu. He'll also show you how to do that as well. Where he says Python 3.1, but it's basically just Python 3 and something, or Python 2.7 and something. The book is based on Python 3. He'll go through and talk more about the print statement and various other topics you've already learned. Hopefully this will help reinforce what you've learned through the videos. And then finally at the end, he'll talk a little bit about comments, printing things on the screen, and waiting for the user to enter, to press exit to complete the program. So I think I've given you everything you need to be able to read through this first chapter in Module 1. All the videos leading up to this point should make it pretty easy to read. And I'm hoping you'll take the time to sit down and read this chapter so that you reinforce the knowledge you've learned. Okay, that's it for this quick review. I'll talk to you later. Well, at this point, you've made it through a lot of videos in Module 1. Hopefully you've read the chapter and you're ready to get started with a simple lab. In this lab, we're going to quite simply make a little script that prints out this is a test. You do not need to use the input function for this one. I want to go ahead and run it from Windows Explorer. Now this is not the same as Internet Explorer. All I mean by this is that we go over to the file and rerun it. Remember that we have learned how, through the videos, to run it from a command prompt. And we've also seen how to hook it up so that it runs automatically from the command prompt when you double click on it by mapping it to be opened with something. Hopefully by now you've learned those lessons, so it should be pretty easy to work with. You'll note how when it's set up like this, it will open and close immediately, but you're going to add an input function to have it stop. You've seen something like this before, so it should be pretty easy to do. That's it. Let's see if that lab works. I'll talk to you later. In this video, we're going to look at the answer to the Module 1 Lab 1 that you have just finished. So let's go back and see what it is. First of all, we want to create a new script using idle that prints out the word text. And as such, I will go through and open up idle. So let's see here. Can't really see it on the screen, but off the left, I'm going through and opening up idle. We'll see that in just a second. Okay, and idle opens. I want to go through and create a new text file to work with. So I'll go new window, and I'll just go ahead and save my work as a file to work with. I made that Python class folder. So what I think I'll do is I'll go through and say lab1-1. And I'm all set up to use idle. Next on the list, this is a test. You know, I might be tempted to copy that whole thing with the quotes, but I gotta tell you, if you do that, the deal is that Microsoft is using something called smart quotes in Word documents. Now, Python can work with double quotes or single quotes. It's very flexible in that regard. Excuse me. But smart quotes aren't part of that. This is a major problem with copying and pasting stuff. I really kind of despise smart quotes. It causes all kinds of problems. But anyway, it'd be all right to go ahead and copy the text, but be careful of those smart quotes. They can drive you bonkers. Okay, so next I want to be able to use that script from Windows Explorer. So I got it working here. I come over to Windows Explorer. I find that lab file, and I double click on it. Hey, wait a second. Well, that's using it, but I'm thinking perhaps more something like this. I probably should open up a command prompt. Change directory to // class. And then I'll just run the Python exe program. And then the file here, I don't know why I navigate to here, just put the full path. Python class. And then the file name is lab1-1.py. This is a test. Cool. We got that part working. We're going to add in the input function so that when the user presses enter, it closes down. Well, that's easy enough to do too. I'll just come over here and say input. I think this is a joke, right? Press enter to exit. So true. Save my work. I should be able to hit the up arrow here and test that it works. Cool. I should also be able to come over here and test that it works. Cool. And of course, I could also test it in idle. Yep, I don't have to enter anything. I just have to enter, just hit enter. Cool, that's it. So that was lab 1. Pretty simple little lab. Obviously, other ones will be more complex, but that'll get you started just to get the feel of how these labs are going to work. That's it. I'll talk to you later. Bye. Well, hello. You've made it all the way through Module 1. Now it's time to do the assignment. The assignment, of course, is this noted in the assignment 1 document file. And of course, what it does, it outlines what you need to perform, the actions. You've already performed step 1 if you made it here. That means you've watched through all these videos. Now there's other videos to go watch and Word documents out on web to see. The thing is with Python is that you're making these little script files to perform some kind of action, but they don't have a whole lot of significance to you. They act like these little programs that would run in the background, perhaps when somebody started the computer, or maybe you click on something and it performs an action like mapping a network drive or connecting to an FTP site. Could be all kinds of things. Could be something as like this. You have a set of 5 computers in a test lab someplace. You double click on a Python file. The Python file kicks off and it goes through and copies files from a master shared drive and distributes them on all 5 computers so that people can start testing against the various different machines, on the various different machines. Lots of things can be done with Python, but kind of understanding the big picture, how it all goes together, can be a little difficult. So the way I've structured this learning activity, this assignment, is for you to go through and look at some things that are similar. First, it talks about MS-DOS. It talks about how batch files and stuff work, and shows a video on how batch files are used. I'm going to have you go through and make a very simple program. At this point in time, it should be pretty easy to do since we've talked about all these topics. In other words, you know about an input statement. You've also seen the use of change directory. You've seen how we can start kickoff commands like Python exe in the name of a file. All these things should be pretty easy to understand, especially once you watch the videos and read those little links I've given you. Now, when you're all done, I want you to describe how you went through the process of making a batch file work. And the easiest way to do that is to hit your, as you're going through and making this, hit your print screen button on your computer. Now, if you're using a Mac, you'll have to hit a different combination. I can't remember what it is, but you probably by now have learned how to do that. And then just paste it into a Word document. So I would go through and I would hit print screen. I go through and I start making a file, like, let's say an idle. And I hit print screen, I get a copy of this, and I paste that image into a Word doc, which is basically how I did a lot of this stuff here too. And then once you get pictures of the steps that you take, you then go back and then you fill in the blanks by writing text to identify what you did in the picture. When you're all done, you go through and clean it all up and make it so that it's legible. Your audience is me this time. I want you to go through and explain what you did to create a batch file that launches a Python script. It doesn't have to be real fancy, but please make it look professional, as identified in this little paragraph here. When you're all done, zip everything up, including your batch file and your Python script file, and send it to me. So hopefully that makes sense, especially now that we have a little bit more context to talk about it. And I will look forward to seeing your work. When you get done, you submit it, you are done for the week. So congratulations, and I'll look forward to seeing you in Module 2. Until then, take care.